Good day, grade 7 learners. This is Super Mom Z, and welcome to Sci Amazing Learning Videos. In the previous video, we described motion in terms of speed, velocity, and acceleration. For today's episode, we will learn how to visualize motion using diagrams and graphs. Get ready, because here we go! Most essential learning competency. The learners should be able to create and interpret visual representation of motion of objects such as state charts and motion graphs. We already know that motion refers to a change in position for a particular time interval. Describing motion is not only limited to using words or equations. Visual representations like diagrams and graphs are also useful tools in describing the motion of an object. Let's start with diagrams. Diagrams are visual representations that use pictures or symbols to illustrate and explain an idea or information. In the examples below, there are measurements like time and distance. A type of diagram is a ticker tape diagram, commonly known as tape diagram. It is produced using a ticker tape timer. A ticker tape timer is a long strip of paper that passes through a printing device that is attached to a moving object. As the object moves, the tape is dragged through a ticker, leaving a trail or mark of dots. These dots represent the object's motion. Distances between the dots represent the object's speed. Try to look at the tape diagrams below. The dots have varying distances in between. Let us try to analyze diagrams A and B. Try to compare the distances of the dots in diagrams A and B. Right, the dots in diagram A have longer distances than diagram B. What does longer distance mean? What about shorter distance? Correct. Longer distance means the object is moving fast, while shorter distance means the object is moving slow. Are the distances of the dots equal in diagram A? How about in diagram B? What do these mean? Nice catch! The distances of the dots are equal, meaning the object is moving at constant speed. Therefore, there is no acceleration. Now let's check out diagram C. Describe the distances of the dots in the diagram. You got it! The distances of the dots are increasing. So what does this tape diagram suggest about the object's speed? Good job! The object's speed is increasing, which means the object is accelerating. We got another diagram. Describe the distances of the dots in diagram D. You're right. The distances of the dots are decreasing. And what does this tape diagram suggest about the object's speed? Exactly. The speed is decreasing. Therefore, the object is decelerating. Wow, you really understand how to analyze diagrams. Now let us look at another visual representation, motion graphs. Graphs are visual representations that use lines to show how measurements are related to each other. One entity is represented on the x-axis of the graph, while the other is represented on the y-axis. To make sure that the information is properly represented in a graph, a graphing paper is usually used. Let's have an example. Suppose that a ball is rolling fast on the floor. The diagram shows the positions of the ball at certain time intervals. Let us fill up this table to easily visualize the measurements we will plot on the graph later. Initially, the position of the ball at 0 seconds is 0 meters. Next, after 5 seconds, the position of the ball is at 5 meters. At 10 seconds, the ball has traveled 10 meters. Finally, at 15 seconds, the ball has traveled 15 meters. Now that we have filled out the table with the data from the diagram, we are ready to plot them on the Cartesian plane. As you can see, time lies on the x-axis, while position lies on the y-axis. We will plot the first pair of measurements. Find where the lines intersect. 0 second and 0 meter. We will plot it here. 5 seconds and 5 meters. This is where they intersect. 10 seconds and 10 meters. This is where the point will be. Lastly, 15 seconds and 15 meters. There you go. The lines intersect at that point. The next thing we'll do is just connect the dots with the line. This is an example of a position-time graph. This type of motion graph describes the position of an object at any given time. The slope of a line shows the direction and steepness of a line. It gives us an idea about the motion of an object. Now try to analyze this graph. What is the position of the object at 10 seconds? The position of the object at 10 seconds is 10 meters. Fantastic! Flashing on your screens are 4 motion graphs showing different lines, curves, and slopes. Which graph shows that the object is at rest? Good! Graph A shows that the object is at rest or not moving. The object does not change its position. Let's proceed. Which graph shows that the object is moving at constant speed? Wonderful! Graph C shows that the object is moving in constant or uniform speed. Uniform speed can be observed if the object travels in equal distances in equal time intervals. This also indicates that there is no acceleration. Next, which graph shows that the object is speeding up? Yes, graph B shows that the object is accelerating. The motion of the object is speeding up or increasing. How about which graph shows that the object is slowing down? Correct. Graph D shows that the object is decelerating. The motion of the object is slowing down or its speed is decreasing. Another motion graph is the distance-time graph. It describes the distance traveled by an object at any given time. In this example, what is the distance traveled by the object at point C? You got it! The distance traveled by the object at point C is 3 kilometers. What can you say about the object's motion at points D and E? Wonderful! The object is at rest since there is no change in position at these points. Here's another motion graph. We call it the displacement-time graph. It describes the displacement traveled by an object at a given time. Looking at this graph, at which times did the object gain 1 meter displacement? Right. At 1 second and 12 seconds, the object has 1 meter displacement. Lastly, we have the velocity-time graph. It describes the velocity of an object at a given time. In this graph, what is the velocity of the object at part B? Since the graph shows a horizontal line at this part, its velocity is constant at 30 meters per second. Here's another question. What happened to the velocity of the object from parts B to C? Looking at the steep slope here, the object's velocity increased, which means it accelerated. Wow, you did great today! And that's all for visual representations of motion. I hope you can now create and interpret your own motion diagrams and graphs at home. Thank you for watching this amazing episode. See you again next time. Bye!